Welcome to the last chapter in the IPv6 Fundamentals book. Here we're doing chapter 13, OSPF, version 3. Again, all of this material is written by Rick Graziani. All of it's copyrighted by him. Here again is the book that we're going after. We're doing the IPv6 Fundamentals. You can all see it as live lessons. Again, written and prepared by Rick Graziani. The appropriate ISBN numbers are listed there. Again, all information is written and owned by him. So let's go ahead and jump right in. Let's talk about protocols and concepts. Here we have again distance vector link state protocols. We're looking for the separation of IPv4 and IPv6, similar to our last chapter when we talked about EIGRP, but in this chapter we're talking about OSPF. Again, we're looking at OSPF version 3, and this is one protocol that's kind of interesting because it supports routing of both IPv4 and IPv6. So you don't have to worry about doing two separate instances of a routing protocol, because this one routing protocol does both. Basic operations and algorithms for IPv4 are pretty much identical in IPv6. Again, different versions, the different prefixes, link states, how we do our metric, router IDs, designated routers and backup designated routers. So you'll notice almost everything is identical with the exception of advertising of routes, and that's going to be the appropriate either IPv4 networks or the prefixes, or we're talking about address families, we're talking about a combination of networks and prefixes. So again, when we look at version 2, and we look at the traditional version 3 for IPv6, here again we're looking at our source addresses. It's going to be the IP address or link local address if we're talking about IPv6. Destination is going to be a multicast address, multicast 005. I say the word multicast because again, this is a specialized multicast address. This is a specialized multicast address. These represent 0s and 5. So you're going to notice they're very similar. If we're talking about the destination of all of our designated routers and backup designated routers, again, multicast 006, multicast 0s and 6. We have our destination neighbors. They're going to, again, use the appropriate addresses, whether it be an IPv4 address or a link local address. Unicast routing for IPv6. Again, not necessary for version 2 because it's not doing IPv6, but it is required for the traditional IPv6. We look at authentication. Here it's going to be where it deviates. OSPFv2, MD5. OSPFv3, IPsec. Alright, next are going to be the LSAs, or the link state advertisements. OSPFv3 renames 2 LSA types and defined 2 additional LSA types that don't exist in OSPFv2. In OSPFv2, we have the 7 common LSA types: router LSAs, network summary LSAs, AS, bridge routers, AS external, root membership, and NSSA external LSAs. So again, the renamed areas, the network summary is now an inter area prefix. The ASBRs are now an inter-area router LSA, and we added 2 new ones, a link LSA and an intra-area prefix LSA. Alright, so before we go on, I want to talk about a few more things. So one of the interesting things here is the intra-area prefix LSA is one of the new types in OSPF version 3. So is the inter-area prefix. This information was carried in the route and network LSAs types 1 and 2. The interesting thing here is OSPFv3 does also change the information that's carried in the Type 1 and Type 2 LSAs. There is no IPv6 specific information in them, which is different from OSPF version 2. The LS types of an AS external LSA is set to the value of, you'll notice here, 0x4005. That's so that it has an external LSI has a AS flooding scope. You'll notice that that is one of the only ones that's different from the rest of them. Alright, let's go ahead and get into more OSPF v2 and traditional OSPF v3. Again, you're going to notice that they're going to have a neighborhood table, a link state database table, and a routing table. OSPF v2, OSPFv2 for the link state database table, and IPv6. For IPv6, I totally said that backwards. Let's grab my pen. OSPFv2 has a neighbor table, a link state database, and a routing table. For OSPFv3, same thing. You're going to have a routing table, and these are managed and kept separate. So we have a dual stack topology where we can do both OSPF, IPv4, that's going to be the v2, and we can do OSPF v3 with IPv6. So if we're doing just a traditional show IP int brief, you're going to see that this is uncommon, or serial cables are uncommon in topologies. We're just using them again to separate our LANs and WANs. If we're looking at our IPv6 int brief, you can see again a link local address and a global unicast address. Again, link local are going to be common on that link only. So let's go look at a basic configuration for v2. You'll have a default route. You'll have the appropriate router OSPF process ID, the appropriate router ID, the passive interfaces and the network statements, and the appropriate areas that they belong to. And so forth and so forth. What's really funny is here we should also be doing, again, OSPF instance 1, router ID, and the appropriate network statements. You can do this shortcut where you can do the interface IPOSPF instance number or process ID and the appropriate area, though typically you end up doing it this way with the appropriate passive interfaces and network statements. You can verify with a IP route OSPF that will only show OSPF routing protocols. Neighbor statement, again, similar like EIGRP, except here we're doing the neighbor statements and what priority they're in and what states they're in. Again, OSPF v2 and v3 both use a 32-bit ID. Here we have a show IP OSPF data. This is going to show you the link IDs, the appropriate ages, sequence checksums, and links. Oh, we'll go back one, and the appropriate areas if you have multi-area OSPF set up. So let's go and look at a traditional OSPF v3 configuration. You'll have a route, an IPv6. You'll have to have the global unicast routing. You're going to have the unicast routing for IPv6 up in a global configuration. That way it will actually process IPv6. You'll be setting the appropriate OSPF instance. Again, process ID. This does not need to match the other routers, but it's a good idea. Uses the same process as version 2. Passive interfaces, similar. Default information originate, again, similar. And now we actually move this to the interfaces. IPv6, OSPF, the process ID, and the appropriate area. That's how you can tell it if it's going to be belonging to that OSPF area. Criteria for the router ID, you can either manually do it, or you can have the highest loopback. Third, you don't manually do it and there's no loopback, then it'll look at the highest active interface's IPv4 address. Then that becomes the router ID. Again, notice the appropriate process ID. And again, for the appropriate serial interfaces, all the way through. Router 2, same thing. Router 3, again, same thing. You set up router OSPF with the process ID. When we're doing IPv6, you're setting router ID, the passive interfaces, the default originate, and then you're assigning the appropriate interfaces to OSPF, the instance, and the appropriate area. Let's verify. Show neighbor, similar to IPv4. Route, again, similar to IPv4. What about multi-area? Area 51 is a totally stubby area for OSPFv2 and OSPFv3. So let's go and look at how we would configure this. R2 would be a area bridge router. If we're looking at R2, you'd be setting up, again, OSPF, area 1, or OSPF instance 1, instance 2. That would mean that this is going to be for IPv4, this would be for IPv6. Go to the appropriate interfaces, the appropriate statements with the appropriate areas that they belong to. That's going to be these guys over here. For the OSPF 1, you can have an area stub no summary. For the router 2, stub no summary, because this was classified as a stubby network. So on R3, all going to belong to area 51. And again, same options. You're going to apply the appropriate OSPF commands to create the instances 1 and 2, and then assign them to each of the interfaces that are appropriate. Call them stub, because again, this was defined as a stubby network. Now let's go into R3. If we're looking at IPv4, we can do a show IP route, OSPF. That will give us the appropriate OSPF output with IA. IA is inter-area. Got ahead of myself again. Okay, that's going to be showing the inter-areas for the links between R2 and R3, and the link between R3 and its LAN. If we want to see the routes for IPv6, again, same command, show IPv6 route OSPF. That will give us the appropriate OSPF updates. It will show us for IPv6 routes. Here we have O and I. O and I is code for OSPF inter. Just like before. So with totally stubby networks, you can do a show IP route OSPF, and you're going to see that this guy will have a default pathway back to R1. This is the default route injected by the area bridge router, not the default originated by the ASBR, which would be R1, because ASBR is going to be the autonomous system bridge, and it's going to be, this guy's leaving area 51 and going to the ISP's area 0. Verification for route, again, the ABR will send its defaults. For R2, we have different areas that we can be doing underneath OSPF. Notice here, IPv6, router OSPF version 2. These are the different areas that we can do. Like we already did the default information. We have distances, distance lists. We have a few other options here. A big thing also is this auto costs. And that's going to calculate OSPF interface costs according to the appropriate bandwidth. Default information we've already looked through. So what of the subcommands can we have when we're programming it per interface? So we're on R2, we're at the serial 000 interface. We want to set up IPv6's OSPF. We do a question mark. What's there? Well, typically it'd be the next process ID, but you can manipulate this so it's not the process ID, but additional, like the hello timer, the flood reduction, or the neighbor. You have the several other options. Cost is another one. Dead timers, hello timers. So let's go ahead and look at OSPF v2 and v3. So here we have the addresses. Again, no stub network because it was listed as a non-stub network. Here again we have IP. That's going to denote IPv4. OSPF 1 is going to correlate to the IPv4 version. Where's my mouse? IPv4, OSPF1, OSPF1, that's going to correspond to IPv4. Here we have OSPF1, again, same thing, IP. Where the next one, OSPF2, you'll notice is distinguished between IPv6. IPv6 and OSPF2, because this one is going to be set for IPv6. So let's get into address families. Pretty similar to what we were doing in EIGRP, but with address families, again, we have our different routing tables for IPv6 and IPv4. So what that allows us to do is have both. So with an IPv6 network, all OSPFv3 address family messages that include IPv4 and IPv6 and IPv6 packets on top of an IPv4 network. So let's go and let's look at this. So we have assumed that all interfaces have both an IPv4 and IPv6, and there is no routing protocol set up yet. We're going to set up our static routes on R1 for both IPv4 and IPv6. We're going to set up unicast routing. We're going to set up OSPFv3, process ID, address family. We have an IPv4 address family and an IPv6 address family. So if we enable if we enable the address family for IPv4 unicasts, again you'll notice that we go to our -f, our address family subclause. If you do a question mark at our -f, you can see all the appropriate items. Again, this is very similar to what you would have seen if you did a IPv4, looking at the router OSPF and process ID. You'd see again similar items here: the auto cost, the default information, the distribution list. All of that is similar. Router ID, passive interfaces, prefixes, everything. So let's talk about how we configure these address families. Underneath an address family, we're going to go ahead, we're going to assume that this is going to be the portion for IPv4. So we're going to do all the configuration for IPv4 underneath this address family. Default information, the router ID, the appropriate passive interfaces, and when we're done, we're going to do exit address family, or exit, so we can back out of that subinterface. Then we're going to go ahead and program the IPv6 address family. Again, similar, we're going to set up the router ID, information originate, set up the appropriate passive interfaces, and we're golden. We also have to, again, double check our interfaces. Make sure that our interfaces are configuring to the right addresses and to the right areas. So here we have gigabit 0, 0. That's this guy right here. We want to make sure that OSPFv3 process instance 1 for IPv4 is set to area 0. Same thing for IPv6. Process ID 1, area 0. That way this will belong to area 0. For our serial interface, this guy right here, again, we're going to set it for both IPv4 and IPv6. On R2, again, same thing. Make sure that we're also making sure that it's a stub network. Address families for IPv4, family addresses for IPv6. Again, the router ID, the appropriate stub, and that's our basic configuration for R2. We have to make sure to do the appropriate interfaces, all three of them. Notice that one did not do a gigabit because there is no, it has a linked local address, but there's no other information given, so there may not be a LAN network up there. Let's go ahead and look at R3. Again, identical to what we've been doing for the last several slides with R1 and R2. Setting the appropriate interfaces, setting up the appropriate IP versions in the appropriate areas. That's a big thing. This is where most people screw up, is areas and IP versions. If we're talking IPv4, we need to make sure that we're telling it IPv4. If we're talking IPv6, we need to make sure that we're doing IPv6 with the appropriate areas. And here again, we do have a LAN, so we'll be doing the gigabit 00 as well. Let's get through some of our show commands. Show IP route OSPF, that will show us the appropriate route table. But why did OSPF not do anything? That's because we're not using that. We're using OSPFv3. So we have to distinguish between the two. You have to make sure if you're using OSPFv3, you're doing the show IP route with the appropriate OSPF versions. Okay, you'll notice that it's a OSPF IA, OSPF IA for enter area. There we go. Because it's going to belong to that area. If we're doing a show IPv6 route, there we go. Even though this should show all routes within OSPF. If it doesn't, again, v3. Alright, show IP route OSPF v3. Notice it won't show anything but the appropriate default gateway and, again, the enter area. So, let's go back a few. This one shows the two IPv6 links, but when we do v3 on R3, we only get the default route. Why is this one not showing the rest of the information? Again, the default route injected by the ABR. So let's go and do an IPv6 route OSPF. We'll see no routes on R3 except for that default route. That's because, again, the choice should be for the default route as the successor, so it won't show the other ones because they're now going to be backups. Default route is going to be lowest metric, so it's the one that will be used. We can always look at the neighbors. Again, we are using version 3, so we have to do a show OSPFv3 neighbor in order to get the neighbor statements, or get the neighbor output. Here, you're going to see it's based off of address family, IPv4 and IPv6. If we're looking at our neighbors, they may not always show up. Traditional OSPF commands show only the IPv6 neighbors. Making sense of the OSPF keywords, show IP OSPF, IPv4, IPv6. So you'll notice here, these are the same, except for this is version 4, this is version 6. When we do this guy, it's going to refer to OSPFv3 and both IPv4 and IPv6. Both IPv4 and 6 neighbors will be displayed, but you have to configure it to use OSPFv3. So let's go ahead and let's look at the link state database. So if we're looking at the OSPF database, nothing will happen. But if we do a OSPFv3 database, you'll notice that now we can actually see outputs. Because again, we configured it to use OSPFv3. And it will show the appropriate address families and the appropriate router ID. How do we configure the address family configuration? We've already gone through this with the IGRP. So we're doing the same thing, but with OSPF. Make sure unicast is enabled. Go to the interfaces, IPv4 address, IPv6 addresses, then the appropriate OSPFv3 for IPv4 and for IPv6, and then configure the routing commands. Router OSPFv3 one instance, that'll be for IPv4. You can also have the address family for IPv6, all using the same instance or the process ID. Okay, and again, the appropriate passive interface is the appropriate default information, originate, and the appropriate router ID. So let's go and talk about address families and the IPv4 island. So if we have just two routers, again, we can set up the appropriate unicast routing, we can set up the addressing, we can set up the OSPF instances, we can set up the address family, the router ID, the stub, and whatnot. But what happens when we add just an IPv4 router? We don't want IPv6 on this network. This one just happens to be running IPv4, hence the island. R4 only has an IPv4 connection with R3, so that's what we're going to have to be doing. So we'll be configuring R3 and R4 to use OSPFv3 with address families. We're going to go to that interface, program them. Again, here, IPv6 is not enabled on this interface, so we cannot do a IPv6 address, and OSPFv3 will actually give us an error once we do it. Not an error, but more like a warning message. We can actually enable IPv6. This will automatically create an IPv6 link local address on that interface using the EWA64. It won't have a global unicast address, so that's okay. Alternately, we can always just create a IPv6 link local address and be okay with that. This will have an IPv6 network even if it's not actually being used. That way we can actually do it and it'll take it. Because while this is going to be a warning message, it will not process that line without IPv6 being enabled. We have to do IPv4 and IPv6. So if we're just using a link local address, then that will work. Alright, so how do we configure R4? You'll notice that once you try to do OSPFv3, you get another error because you're not using IPv6 unicast routing. So you'll have to turn it on. Then you can do it. You'll set up the appropriate address family. You'll probably get an error because you'll have to be able to do a manually configure the appropriate router ID. You still have to be able to configure the addresses on the interfaces as outlined right there. Do the appropriate router ID, the appropriate area. And again, we'll have to go to each of the interfaces, make sure that IPv6 enabled is on. We will create a OSPFv3 instance. Process ID will be the same for IPv4. And that's it. We won't do a link local address here. Ngig 0, we'll just do an IPv4 address. We'll enable IPv6. That will create a link local address. And that will allow us to use OSPFv3 and assign it to that area. The sad part is, while this is a IPv4 island, we just enabled IPv6 on it, which means they're going to have IPv6 addresses. So indirectly, you still have to have IPv6 addresses on them, even if you're not going to be using them. So let's go look at the routing table. There you go. Default route, summarized addresses. If we're doing a route OSPF, you'll get nothing, because again we're using v3, so there you'll get the appropriate outputs, because they're going to pull up the information from the other inter area. It's all one giant area. So our bridge router will send the default route, and then the appropriate networks from inside. You'll notice it will only do IPv4, because even though it has an IPv6 address, they're using just link local. So with R1's OSPFv3 and just IPv4 routes, you'll see that again, just IPv4 routes are going to be enabled and showing. When we're doing this on R1, again, show IP. If we want to see the version 6, it'd be show IPv6. Inter-area IAs, again, inner areas. We can always do the debug, so we can see hello details, the multicast address, back and forth. So again, even though this is only supposed to be IPv4, you're going to see that a lot of them are going to still be coming from IPv6. OSPFv3 messages are used or sent over IPv6. So if you want to use OSPFv3, IPv6 has to be enabled. Even if you're just using link local addresses, that's okay. FF02::5 is the multicast address for the OSPF router. If we're looking at our neighbors, again, this is using OSPF version 2, so you cannot use this guy. When you do v6, it's assuming you're doing version 3 of the OSPF, so it'll show you some information, but for everything you want to be able to get OSPFv3, because that's going to show you all of the information that you need. Address families for both IPv4 and for IPv6. So again, let's go and look at our big picture again, R2, R3, and R4. Again, our addresses, our areas. Here's our different instances. Here's OSPF for IPv4, for IPv6. Here we have again the other interface with IPv4 and OSPF just for IPv4. Yes, it has an IPv6 link local address, but that's it. How do we configure it? We've already walked through it. So let's go and look at the OSPF configuration at a glance. We can do the network statements because we're doing OSPF. R1, R2, R3. And that's the end of this book. So again, this is IPv6 Fundamentals. All of the material was written by Rick Graziani. There's the appropriate ISBN numbers for both his video and his textbook. All information is owned by him. If you have any questions, please let me know. Thank you.